So our customers that do this, like I said, it's this fantastically interesting nested problem where we want to store things the most effective economically, but the things that we want to store are both really little, the things that we're working on right now, and really big, all the things we might want to work on. So we have to figure out how to manage all that. And then once we identify what the really little things are that we want to be working on today, how do we get them into the right place at the right time, given that these constraints now exist
Okay.
with tremendously low latency requirements? In fact, the latency requirements for these workloads are so low that really we want the working set whenever possible just to be inside of a memory.
And let me throw a question your way. So you work quite a bit in the storage world, certainly with our customers, among the many areas you delve into. So our customers for years have been experiencing this geometric growth in storage capacity. We got more data that we have to store. We've got more customers. We've got more transactions. We've got more log entries. All of this is growing, growing, growing. Are you seeing, like with AI, that yeah, we're still growing at that rate, but now we have to tap on top of that things like moving all that data into vector databases so it's readily consumable by inference engines in training?
Yeah, of course. Like we were just boiling it down to the three components. But yeah, within it, I think, Mark, this is an area, an endless well of fascination for me. So as I've pointed out, you brought up storage in the enterprise, and the problem space is very familiar, right? We have stuff that we want to store, and we're starting to see all of this amazing stuff first come out of the storage company so that they could scale bigger and be faster where it's appropriate, all those things. It's an amazing time for that. We're starting to see abilities to tier within one management framework so that you could have very cheap and deep storage affiliated with super fast storage and everything in between. I oversimplify this in my mind, but I think about databases in many ways as being a file system. It's just different ways of accessing it. Instead of asking for, Mark Campbell's glamour shot, I might be using a database query to go ask for that, right? So vector databases are something that we're starting to see employed. And so, yeah, it's like a fractal. The closer we get to these problems of what good looks like for our customer, the more we find out that there's more knobs for us to turn, more things that we can tune, more ways that we can help our customers deal with their data.
Well, something that we've had a lot of conversations with our customers about, and you kind of mentioned like tiering within like a manufactured framework, this vendor's arrays of storage, for instance. We're starting to see that even kicked up a level to where we're tiering across storage farms and across geo sites. And the one of the drivers for that is when we're trying to train these AI models, we need all this data. We don't need a lot of complexity and where is it? Where is it stored? How do I go get it? So we're starting to see the emergence of either storage aggregation or data virtualization in there to help just reach your hand out and grab all the sales data for Cleveland, and it magically comes from wherever it was stored in the shortest latency that we can get, so the training goes on at light speed.
Well, this is also a fantastically interesting area, not just for these types of workloads, but just in general. Coming back to the very first way you introduced it, Mark, this geometric or logarithmic explosion of data that's stored. Well, it's being stored for a reason because it's valuable.